In today's lesson, we're going to be expanding on what we learned about logarithms in the last video and looking at log laws. Now, there's a couple of laws, or more than a couple, and I'm just going to detail each of them quite simply and in a general way, and then we'll talk about them with some examples. So, first of all, the product law. Now, the reason why we're talking about laws at all is because logs are rearranging of like exponents, things with a power. So they have similar laws here as we have with exponents. I'll show you what I mean. So for the product law, first of all, I'm going to write a log. So I've got log, and I'm just going to pick a random base. So I'm going to use A. And if I have a log with two numbers being multiplied together, I can actually split it into two logs with the same base. So I'll show you what I mean. So I've got here log base A, x times y. And that's the same as writing log base A, x, plus log base A, y. Okay, and that works both ways. So if I've got two logs with the same base, and then I've got two numbers, but they're being added together, I can then bring it into one log where I multiply those numbers together. So the division law, and sometimes we use the word quotient instead of division, is similar but with division, and that means we're going to have subtraction instead of addition. So if I have a log with a base, and in it I've got a number divided by another number, I can rewrite that as a log with the same base, with the thing on top, minus log with the same base, with the thing on the bottom. Now, one thing that's important here, the product law, it actually didn't matter which one I put here. I could put the x or the y there, it wouldn't matter. But here I can't switch them, because whatever's on the bottom needs to be subtracted. That's quite important, otherwise it doesn't work. Okay, so next we have the power or exponent law. So the power law is if I have something like this, so I've got a log with a base, but the thing in the log has a power. So here I've just given it to the power of n. We can do something pretty cool, and that is I can actually bring this power to the front. So I can rewrite this log as n log base A x, and then the n at the top is gone. And this works both ways as well. So if I've got a number in front, I can bring it up here, or if I've got a number here, I can bring it to the front. The way I want you to think about this is, why does it all matter? It's all about problem solving. It just gives us extra tools. If we couldn't do it one way, maybe we can do it this way if we do some changes. Now, one law that actually isn't in this exercise for the textbook when you move on to it, but you can definitely use it, is the change of base law. Now, I mentioned in our last lesson, you can't type logs into the calculator unless it's got a base 10. Well, actually, you can if you do a change of base. Because like I said, if the base is 10, then it can be typed in the calculator. So if you can change a log to have a base of 10, then we can type it in. So the way it works is, let's say I've got a log here, log base AX. I want to type that into the calculator. Of course, I couldn't do it because the letters are not numbers, but that's okay. We'll do an example later. If I've got a log base AX, I can rewrite it as this. Log base 10x, so the thing that's bigger and above goes on top of a fraction with the same log with the base, with the other number, the smaller one, below it. So a quick example of that, if I had, say, log base 2, 3, and I want to know what that answer is, I can type into my calculator log base 10, 3 over log base 10, 2. And I'll quickly type that in, see what I get. So I get log 3 on log 2. It gives me 1.5849, and so on. So I took something that looked like this, which up until yesterday we couldn't do anything with, and now we can. Now we can actually get that answer from the calculator. Now that's the 4 laws. So we've got product law, quotient law, exponent law, and base law. Okay. The properties of logs, though, there's 2 that are pretty important. So the first one is something like this. Okay, so if I've got log base A, so if these 2 things match, then it always equals 1. Okay. The other thing that's interesting is log base A1 always equals 0. So it doesn't matter what the base is. If that number is a 1, then the whole thing equals 0. And I'll quickly show you why that's the case. Let me just move this out of the way. The reason why that works is because if I rearrange it, this is a BAP, so I've got the BAP thing. So the base is A, the power is 1, the answer is A. So A to the power of 1 is equal to A. Well, of course it is. And that's why that is a true property. Another true property is this. If I do the same thing, so BAP, the base is A, the power is 0, that equals 1, because anything to the power of 0 is equal to 1. So that's why those properties work. All right, so now let's do some examples. So the first example we have is evaluate log base 5 to the power of negative 2. So for this, the first thing I'm going to do is I'm going to use the exponent law, to bring that to the front. So if I do that, I'm going to have negative 2 log base 5. And one of the properties was if these 2 numbers match, then this whole thing is equal to 1. So this is the same as negative 2 times 1, so the answer is just negative 2. For B, we've got log base 2, 5 minus log base 2, 10. So for this one, we actually have a subtraction with the same base. These bases match. So I can rearrange it as log base 2, but I'm going to have 5 divided by 10. So that's using the quotient law, which is the division law. And I can simplify that. That's going to be log base 2, 5 over 10 is a half. And most of the time that's all right, but we can actually take it a bit further because this half I can rewrite as 2 to the power of negative 1. Okay, now you may not remember that too well, but that's the reciprocal. This little thing here means the reciprocal power. And the way I like to remember it is this negative becomes the fraction, and then a 1 just goes on top. So I can then do the exponent law, which is to bring this to the front, and I'll end up having negative 1 log base 2, 2. And they have the same base. They have the same number. Base and the 2 are the same. So that's the same as negative 1 times 1. So I can just write the answers to that is negative 1. All right. Now for C, we've got something similar, but you'll notice there's one thing here we can't just do the quotient law straight away because this 2 is stuffing things up. If it wasn't there, we'd be able to do log base 3 and then do 6 over 4. So instead, I can actually get rid of that by bringing it up here. So I can rewrite that as log base 3, 6 squared minus log base 3, 4. Which I can simplify the 6 squared. That's going to be 36 minus log base 3, 4. And now I can do the quotient law. So the quotient law would be log base 3, and I'll have 36 over 4. And 36 over 4, that's going to be it's going to be 9. Okay, that's good. So we've got log base 3, 9. But we can actually simplify that further because you'll notice it says to evaluate. Evaluate means that we want a whole number at the end, or at least close to it. So far we haven't actually evaluated it yet. But this is something that most people, when they're working with logs for the first time, they don't see this, but hopefully you will eventually. We can rewrite the 9 as 3 squared, because 3 squared is equal to 9. I can then bring the 2 to the front using the exponent law, and then log base 3, 3 is equal to 1. So that whole thing is equal to just 2. So that's the evaluation there. All right, we've got one more to do before we go to the next example. So for this one, we've got log base 5, 10 plus log base 5, 2 minus log base 5, 4. So the first thing I'm going to do is I'm going to recognize that these are addition, so I can actually make them a multiple. So I'm going to rewrite that as log base 5, 20 minus log base 5, 4. Now log base 5, 20 minus log base 5, 4, I can do that as a division or quotient law. That's 20 over 4. And 20 over 4 is equal to 5, so that's log base 5, 5. And that's just equal to 1. So it looks a bit complicated, but if you take your time, it's actually not too bad. When I was at school, I didn't like these, but that's because no one explained them to me particularly well. I've gotten a lot better at them over time, and hopefully you will get better at them too. All right, we've got one more example. Two more examples, but these ones are a bit quicker. We've just got some more logs, but you'll notice before it was an evaluation, this is a simplify, and that's because we have unknowns or variables, pronumerals. So we're going to have to work with that. So first of all, we can see that we've got some exponents here that I want to get rid of to the front. That's what I'm going to do first. So I'm going to have 6 log base AA plus 4 log base AA minus 9 log base AA. But you'll notice I've got a bunch of log base AAs, and that's equal to 1. So I can take them away. So it'll just be 6 times 1 plus 4 times 1 minus 9 times 1. So that's just going to be 6 plus 4 is 10 minus 9 is 1. So that's the answer for A. So for that simplify, we actually ended up getting a whole number. Now you don't always get that, but in this case we did. For B, we've got log base 2x plus log base 2w minus 2 log base 2y. Now, I want to bring them all together, but like before, this 2 is in the way. So we need to bring it up here, so it's gone from in front of the log. So I'm going to rewrite it with just that change. So it's going to be log base 2y squared. Now I can multiply these two together because of the addition, and then I'm going to divide by this because of the subtraction. So we're going to have log base 2 x times w all over y squared. And that's it. That's our simplify. Can't get any more simple than that. For part C, you'll notice that these look basically the same, and it's a fraction, so we might be able to cancel things out, but this 3 is in the way. So I'm going to use the exponent law and bring it to the front. So I can rewrite that as 3 log base 3a all over 5 log base 3a. So they're the same, so I can cancel them out. So I'm left with 3/5. That's all we need to do for that question. Last one here, example 3. It says evaluate 6 to the power of x is equal to 92. Now, the first thing I'm going to do, because I can't evaluate the x, is I'm going to change its form. I'm going to change it to a BAP form. So I've got the base power answer. So that's now going to look like this. It's going to be a log with a base of 6, answer 92, and the p is x. And I can't do anything with that. So I'm now going to use the change of base formula. So for this, I'm going to change it to log base 10, so I can type it in the calculator with a 92, so it's the bigger number on top. And I mean physically bigger, not the larger in magnitude. With the smaller number, as in literally smaller, on the bottom. And that will give me my x value. So I'm going to type that into the calculator and we'll see what we get. Log 92 over log 6 is equal to 2.5236 and so on. So I'm just going to write it to 2 decimal places. And you can test that by putting it back into here. If you check 6 to the power of 2.52 and then go a couple more decimal places, it should get pretty close to 92. And that is why we use this. That's the whole reason. And the more skilled we are at using these laws, the easier it will be. All right, good luck with the work for today. And if you need any help, please send me an email.